Get started. We're going to look at homework problems 20 and 24 from 5.22. So number 20. Cubed root of 3 times cubed root of 18 over the sixth root of 2 times the sixth root of 2. And then we'll look at 24. Fourth root of 4 over fourth root of 27. Well, now if we look at 20, we have the third root of 3 times third root of 18 over the sixth root of 2 times sixth root of 2. So we do need to simplify this here. Now on top, we are going to be able to multiply these together. I'm going to go on and factor 18 into its prime factorizations. Well, we can say 3, or well, it'd be easier to just say 2 times 9, and 9 is 3 times 3. Telling us that 18 is 2 times 3 to the second. And we can multiply that with our cubed root of 3, and that's going to simplify a little bit here in a second. On the bottom, we can multiply those two together and give us the sixth root of 2 times 2. On top, we do have the cubed root of 3 cubed times 2. And on bottom, we have the sixth root of 2 squared. Now on top, our cubed root of 3 cubed is going to be 3. We cannot take the cubed root of 2. Now interestingly enough, this is one of the ones that's kind of a little bit interesting. We didn't talk too much about this here, especially when the index and the number inside of them have a common factor. Because the index is 6, our power inside is 2, so since they both share a common factor of 2, or if we look at this especially in terms of the nth root of a to the x, a to the x over n, well, 6 root of 2 squared would be a, not a, would be 2 to the 2 sixths. And the reason I say this is interesting is because 2 sixths actually reduces to 1/3, which if we rewrote it back as a radical, we can stick it back in as the cubed root of 2. Now there's two ways we can go from this here. One is simplifying and multiplying to get this cubed root of 2 to go away, but let's get a highlighter. Interestingly enough, what's on top? Cubed root of 2 over the cubed root of 2. That reduces to 1, telling us it is 3. That's part of the reason they stuck 6 roots instead of cubed roots, so it wouldn't have been as obvious that they were going to cancel out. But it simplifies down to 3. All right, we can move over here and look at 24. Now 24, the numerator, 4 is going to be 2 squared. Well, that 2 squared, that fourth root, do share a common factor of 2. They might simplify. But if we look at the denominator, 27. 27 is 3 times 9, which is 3 times 3. Or 3 to the third power. Now the fourth root of 4 and the square root of 2 do give us the same value, but we're going to leave it as the fourth root of 4 because even if we reduce it to a square, we don't have a radical that's the same on top and bottom. We'd have a square root on top, fourth root on bottom. We can't multiply different roots together because a square root of just say 3 times a cubed root of 3 is not going to be the same as like the cubed root of 9 or the fourth root of 9. We can't just multiply. Whenever we multiply two things together, erase erase all that. I don't want that sitting there. Like this here where we did the 3 and 18, we can multiply those together. We can only do it if the roots are the same. So if we have different roots, different indexes, we can't just multiply what's inside.
Following students need to go check in with Miss I between classes. Hunter Gooding, Julian January, Emma Lipka, Aiden McChristian, Helen Ward, Cindy Worsham, Lola Hopper, Destiny Jones, Jacob Martinez, Melanie Yang, Saber Haggard, Sarah Johnson, Lara Morrill, Jose Rocha, Hannah Wiggins, Ina Yang, and Naomi Yang. Thank you.
All right, let's focus in, guys. So the issue, or what we're trying to do, guys, focus. What we're trying to do here is to get the radicals out of the bottom of the fraction. So the one we have, 4th root of 27, is the same as the 4th root of 3 cubed. We need one more 3, 4th root of 3, in the bottom of the fraction to get it to simplify. So we're going to multiply the bottom and top of this fraction by the 4th root of 3. Because the bottom is now going to become the 4th root of 3 to the 4th, which lo and behold is 3. On top, because the indexes are the same, we can multiply what's inside, which would be 4 times 3, telling us that we have the 4th root of 12 all over 3. So if we had changed it from the 4th root of 4 to the square root of 2, we can't do that multiplication. I can't just multiply the square root of 2 and the 4th root of 3. Those aren't the same. Yes. Questions on these here? All right. All we're looking at today is solving these here. So these steps for solving, we've had them already. We had these on Thursday. 1, is there one radical? So if we look at this problem here, I'm just going to rewrite it. X equals the square root of x plus 6. Is there one radical? Yes. So get it by itself. Is it by itself? Yeah. Okay, so put both sides to the nth power. Well, the nth power, in this case, would be 2. Now, on the right-hand side, the square root and square would cancel, telling us that we have x plus 6. On the left-hand side, we have x squared. We have x times itself. X squared would indeed be just x squared. So that's 2. Step 3, are there any radicals left? No. So solve. Now this is the first one here that we've had where we've had a variable to a power other than 1. And we do have a middle term, so we have to get this equation equal to 0. We need to move everything to the same side. So the first thing we can do is subtract x. Now on the left-hand side, we'll have x squared minus x. On the right-hand side, the x minus x simplified out, leaving us with just 6. And lastly, we're going to subtract 6 from both sides, telling us x squared minus x minus 6 is equal to 0. Questions on anything we've done so far? So far we did was square both sides, get the equation equal to 0. Now there's two main ways, well there's several ways we can go about solving this. One is factoring. We can factor it, find out what values of x, and make this be 0. We can graph it. We can use the quadratic formula. Or we can do completing the square. I would just go on and factor it. Factor or graph it. So, No. Third term's negative, so the signs are opposite. One's going to be positive, one's going to be negative. Factors of x squared, well, only factors of x squared are x and x. Now in front it's 1, so we just have x and x. Factors of 6, on the other hand, 1, 6, 2, and 3. Which one do we want to try first? 2 and 3. Which one do we want to put first? 2, 3. I'll go on and check it just to make sure. X times negative 3 is negative 3x. 2 times x is positive 2x, giving us the negative x middle term that we wanted. Part of the reason we factor is because now we have two things multiplied together to equal 0. So one of these is going to be 0. Either x plus 2 is equal to 0 or x minus. So with x plus 2, we would subtract 2 from both sides, telling us x is equal to negative 2. With our x minus 3, we would add 3, telling us x is equal to 3. Because the other way we could have done this is graph it, x squared minus x minus 6. And to do that, we would grab the graphing calculator, hit y equals, and say x squared minus x minus 6. And again, we're looking for the values of x that make the y value be 0. So the two places where it says that y is 0 is when x is negative 2 and when x is 3, which we found by factoring also. Now we're going to check this here because our original equation, x is equal to the square root of x plus 6. And we're wanting to make sure that these values work. So the first one I'll check is 3. We're saying that 3 is equal to the square root of 3 plus 6. Now on the right-hand side, 3 plus 6 is 9. Square root of 9 is 3. Left-hand side is just 3. So 3 does indeed equal 3, so that works. Let's check it with negative 2. All right. The right-hand or left-hand side is just going to be negative 2. Left-hand side, negative 2 plus 6 is 4. Now, square root of 4 is 2, but negative 2 is not equal to 2. So it tells us x equals negative 2 does not work. So we had to go back and check it, and especially if the starting equation or at any point before we square it, put it to an even power, if there's a variable outside that radical, we are going to need to check our solutions. Because there's a good chance one of them might not work. Or both. But one of them, there's a good chance might not work. Questions on this here? Let's look at this next one. X equals the square root of 20 minus x. There's indeed one radical. Is it by itself? Yep, so it puts both sides to the nth power. And the nth power in our case is going to be 2. Now the right-hand side's kind of nice because the square root and square would cancel, leaving us with 20 minus x. Left-hand side, x squared is going to be, well, x squared. We have a single term being squared. At this point here, we need to get this equation equal to 0. We can add x, we could subtract 20 first, it doesn't matter which. Because if we add x first, we get x squared plus x equals 20. Then we minus 20. Notice that we have x squared plus x minus 20 equals 0. Because it really doesn't matter if you add x first or subtract 20 first, because whichever one you do first, you'll have to do the other one second. Questions on how we got this equation equal to 0. Now we just need to solve. Do we want to factor or graph it? Let's try graphing it. So we have x squared plus x minus 20. It does look like it intersects at two nice places. Now we can count left and right from center. I do know that we have 1 to the left of the y-axis. We do have one negative value for x. And we do have one positive value for x, because we did have to show up. But we do see the positive value is when x is 4, the y value is 0, like we want. And the other is negative 5. So that tells us x is equal to 4. And x is equal to negative 5. Now it might be good to x square root of 20. So our starting equation was x equals square root of 20 minus x. Now there's a good chance, like we saw in the last one, the negative answer is probably not going to work. So negative 5 equals the square root of 20 minus negative 5. Now on the left-hand side, that's just going to be negative 5. Now on the right-hand side, what we could do is we can take the calculator and plug that in. And you can say second square root of 20 minus negative 5 is 5. Well, negative 5 is not equal to 5, so x equals negative 5 does not work. It's one of our extraneous solutions. We can do the same thing with 4. So we take our equation, and every place there's an x, we're going to plug in 4. Now the left-hand side is just the number 4, so we can just say 4. On the right-hand side, we can do the exact same thing we just did. We can say second square root 20 minus 4 is 4. 4 equals 4 is indeed a true statement, a true solution. So x equals 4 is our final answer. Questions on these here? We're ready for the next one. Square root of 4 minus 3x equals x. Is there one radical? Yes. Is it by itself? Yeah. So we're going to put both sides to the nth power, and our nth power is going to be 2. And luckily for us here on the left side, the square root and square cancel, giving us 4 minus 3x equals, well, x squared is x squared. Now at this point here, we need to get this equation equal to 0, yes? What can we do first? Plus 3x. And then what can we do? Minus 4. Telling us 0 is equal to x squared plus 3x minus 4. Questions on how we got to this point, how we got this equal to 0. So we can factor or graph it. Which one do y'all want to do? Graph. X squared plus 3x minus 1. It does intersect at two nice points, and those two nice points are -4 and 1. Because again, we're looking for where, or what values of x will make the y value be 0. What input values will make the output value be 0. And again, we're going to check it. So with -4, we're saying 4 minus 3 times -4 is equal to -4. There's a good chance this is not going to work out. And part of the reason for that is because there's not going to be a number that comes out of a square root that is negative. We cannot take the square root of a negative number and get a real value. And square root of 4 minus 3 times -4 is +4. Well, 4 does not equal -4. That doesn't work. We try with 1. 4 minus 3 times 1 equals 1. Well, we can do this one by hand. -3 times 1 is -3. 4 minus 3 is 1. Square root of 1 is 1. So lo and behold, x does indeed equal 1. All right. Questions on any of this so far? Okay. (13 plus the square root of 5n equals 3. Is there one radical? So get it by itself. We would minus 13 from both sides. We subtract 13 from both sides. This simplifies, leaving us with the square root of 5n is equal to -10. Is the radical by itself? Yeah, so we're going to put both sides to the nth power. What power are we putting it to? 2. Here the square root and square will cancel, telling us 5n is equal to 100. And then divide by 5. 5n divided by 5 is n. 100 divided by 5 is 20. We'll go on and check it just to make sure. 13 plus the square root of 5 times 20 is equal to 30. 5 times 20 is 100. What's the square root of 100? 10. 13 plus 10 is 23 equal to 3? No. So we know that n cannot be 20. Do we have any other solutions? No. So this here is no solution. It does not work. Now there was kind of a giveaway that this wasn't going to work. And it's at this point here. At this point here, we do have the radical by itself, completely by itself, and it's equal to a negative number. I cannot take a square root. I cannot take the even root of a number and get a negative. It's just not going to work. I can take an odd root, the cubed root of a number and get a negative. We cannot take the even root of a number and get a negative. And in most of the cases where we do have that plus or minus, we're not so much looking at the square root of something equals a negative. We were saying what times itself gave us this negative number. And even that didn't work. So here, this is never going to work out. Because if we look at it graphically, the square root of 5x we can plug in 0, get a value, but as soon as we start plugging in negative numbers, we have errors. It does not work. We cannot take the square root of a negative number and get a solution. And even as we get bigger values of x, that number is just getting bigger. It is not getting smaller going towards negative. It's going towards a bigger, it's going up. It's going to infinity, positive infinity. So this just does not work. There is no solution for even roots. Now, if we said this was a cubed root, that'd work fine. We can take the cubed root of 5n and get negative 10. That works out just fine. But we can't do this with a square root. So, let's look at this one here. The square root of 3m plus 10 equals 1. First step would be to what? Minus 10. Telling us that the square root of 3m is equal to negative 9. What's that? We can do nth power, yes. It is going to be no solution. Because is the radical by itself? Yeah. Square root and even root equals a negative number. It's not going to work. We could keep going. We could square both sides, telling us 3m is equal to 81. Divide by 3, telling us m is 27. 3 times 27 plus 10. Well, 3 times 27 is 81. Square root of 81 is 9. And 9 plus 10 is 19. That is not equal to 1. So that does not work. And even so, we saw that we have the radical by itself equal to a negative number. It doesn't work. If it had been negative square root of 3m, we would need to get the negative over, and it would just tell us that the square root of 3m equals 9, not negative 9. But again, we have to make sure it's by itself. Here, nope, this does not work. There's no solution. That's it. Questions on these? Last type we're going to look at today are these here. So we do have a variable outside the radical, so we are going to need to check the solutions here. But the steps don't change. Is there one radical? Is it by itself? Yes. So we're going to put both sides to the nth power. Now the right-hand side, it works out nice because that square root and square will cancel, leaving us with 7p plus 15. They cancel because the radical, that square root term, is the only term on that side. So that's fine there. On the left-hand side, I have two things being added together that are being squared. So we have to multiply it by itself. We can't just square both the p and the 1. Because p times p would indeed give us p squared. However, p times 1 is plus p. 1 times p is plus p. And 1 times 1 gives us 1. 1 squared or 1. So yes, we did end up squaring the first and second term, but we also have a middle term because our p plus p is 2p. Questions on how we got to this point here? Okay. We do have a squared term and a middle term, so we do need to get this equation equal to 0. So we can subtract 7p from both sides. Telling us that p squared minus 5p plus 1 is equal to 15. Then we can subtract 15 from both sides, telling us p squared minus 5p minus 14 is equal to 0. So it's similar, but we did have to distribute out. We had to multiply out that p plus 1 squared. Our theorem will want to factor this again. But instead of using p, we'll use x squared. X squared minus 2x minus 14. Make sure. Third time's charm. Yep. Oh, 5, not 2. And we can graph that. Now we do see it does cross in two nice places. One of them is negative. One of them is positive. Our two x values would be negative 2 and 7. So our solutions for this here is that p is equal to negative 2 and p is equal to 7. And again, I would definitely check this here. So we can check negative 2 first. Now on the left-hand side, negative 2 plus 1 is negative 1. There's a good chance this is not going to work because we cannot get a negative out of that radical. Seven times negative 2 is negative 14. Now negative 14 plus 15 is 1. Square root of 1 is negative 1. Telling us that p equals negative 2 does not work in the original problem. Now we can also try 7. Now on the left-hand side, it's kind of nice. 7 plus 1 is 8. On the right-hand side, we'll do it in the calculator this time. Second square root of 7 times 7 plus 15 is 8. And on the test, when I say check, that's all I'm looking for. That you plugged in the value and made sure that both sides are equal. Both sides are the same value. So the only solution for this here is that p is equal to 7. Questions on this here? '26. We're going to look at this one and one more, and then we're done for the day. b minus 6 is equal to the square root of 18 minus 3b. Radical is by itself, and there's only one of them. So we can move on to step 2 and square both sides. Again, here the right-hand side, the square root and square will cancel. And they immediately just cancel because we only have one term. We just have that radical. On the left-hand side, we have two terms. We have the b and 6. Since we have two terms being subtracted, we do have to multiply this out. Now our b times b would be b squared. Our b times negative 6 is negative 6b. Negative 6 times b is negative 6b, and negative 6 times negative 6 is going to be plus 36. Now we do have like terms, our negative 6b and negative 6b. Well, they'll combine to give us negative 12b. Again, we have a b squared term and b term, so we would need to get this equal to 0. So we could subtract 18 first, telling us b squared minus 12b plus 18 is equal to negative 3b. Then we can add 3b to both sides, telling us b squared minus 9b plus 18 is equal to 0. Now at this point here, just like we've been doing, I think y'all are going to want to stick with the calculator. We can say x squared minus 9x plus 18 graph. Again, we have two solutions. Incidentally, this time both of the solutions are positive values. When x is 3, the y value is 0. When x is 6, the y value is 0. So here, b is equal to 3, and b is equal to 6. So again, we're going to need to check. Let's start with 6. 6 minus 6 equals square root of 18 minus 3 times 6. Now again, when I ask you to check it on your paper, I'm going to at least want this written out where it's showing that you did plug in our solution in. Well, 6 minus 6 is 0. On the other side, second square root of 18 minus 3 times 6 is also 0. 0 does equal 0. So that checks out. That we checked it. It did work. For 3, we have 3 minus 6 is equal to the square root of 18 minus 3 times 3. 3 minus negative 6 is, or 3 minus 6 is negative 3. Second square root, 18 minus 3 times 3 gives us 3. 3 does not equal negative 3. So the only solution that we have for this is 6. It could work out that both solutions do work. Here, in most of the ones we've done, it's only been nothing stopping us from having two solutions. It's just most of the ones we've had don't have two solutions. Questions on this here? 23 or 22, which one do y'all want to look at? 23. 4 plus the square root of negative 3m plus 10 equals m. So looking at this here, we do have one radical. Is it by itself? No. So we're going to have to subtract the 4 from both sides because our 4 minus 4 will simplify, leaving us with negative 3m plus 10 is equal to m minus 4. Now is the radical by itself? Yes. So we're going to put both sides to the nth power. Well, the power in our case is 2. Because here the square root and square would cancel, telling us negative 3m plus 10 is equal to, well, m minus 4 times n minus 4. It's possible to do these with cube roots. We're not going to get there. And it's not because they're harder, it's just more work. Because if we cubed it, it means that we would actually have m minus 4 being multiplied a third time, fourth time. We're just adding. But we're just doing squares. Here, we'll distribute out. M times n would indeed be m squared. M times negative 4 is negative 4m. Negative 4 times m is negative 4m. And negative 4 times negative 4 is positive 16. We can combine our like terms. Negative 4m minus 4m would give us negative 8m. So m squared minus 8m plus 16. At this point here, we need to get this equation equal to 0. We could add 3m first. We could subtract 10 either way. We will end up getting to the same place. Which is that 0 is equal to m squared minus 5m plus 6. Factor or graph it? Graph x squared minus 5x plus 6. X squared minus 5x plus 6. We do have two solutions. And those two solutions are 2 and 3. Four plus. So our starting equation was 4 plus the square root of negative 3m equals m. So the first value we can check is 2. 4 plus negative 3 times 2 plus 10 equals 2. 4 plus second square root of negative 3 times 2 plus, was it 10? Yeah. Is 2 equal to 6? No. So that tells us 2 doesn't work. Well, let's try 3. 4 plus the square root of negative 3 times 3 plus 10 should equal 3. 4 plus second square root of negative 3 times 3 plus 10 is 5. Even though we had two solutions, neither one of them worked. Questions on this here? Questions on anything we've done so far? And that's it.